Introducing Blinky-Lite, a secure, remotely accessible, full-stack, integrated hardware-software control platform that is completely open source and free to use. But before I tell you more about Blinky-Lite, let's first talk about what a control platform actually is. When most people think of a control system, they imagine a room filled with dials and computer screens. But control systems are so ubiquitous that most people take them for granted. For example, the thermostat in your house is part of a control system. The stoplights in your city are synchronized by another system. You can even think of your central nervous system in your body as a control system. Control systems can be broken into 4 parts. First, there are sensors to observe the surrounding environment. Next, there is some type of intelligence to process the sensor input and decide on a course of action. The intelligence can be a mechanical linkage, an electronic circuit, a computer program, or even a human brain. The third part is a set of actuators to implement the course of action. Actuators can be anything from human hands to the control rods of a nuclear reactor. Lastly, but most important, is the environment that reacts to the actuators and provides input to the sensors, thus, closing the loop. What Blinky-Lite provides is the intelligence part of the control system, receiving input from sensors, deciding on a course of action, and relaying that course to the actuators. Now that you understand the purpose of Blinky-Lite, I need to tell you what makes Blinky-Lite so special. Well, this goes back to the image of control rooms with TV screens and dials. This concept of a control system is great for large facilities that have a 24/7 staff on site. But this way of operating is expensive and inefficient. Things don't go wrong while sitting in a comfortable control room sipping coffee during business hours. Things go wrong in the middle of the night when experts are far away from the site. Also, the world is interconnected as it has never been before. So, an engineer needs access to the control system out in the field, wherever and whenever that may be. To bring the control system to the engineer, Blinky-Lite was designed from the ground up to be a remotely accessible control platform. Sensors and actuators can be located anywhere in the world. All our user applications are web applications that you can use on your mobile phone, tablet, desktop computer, or even sitting in a comfy control room sipping coffee. Since the key feature of Blinky-Lite is remote access, security is the driving force in the development of Blinky-Lite. To be secure, a control platform must be complete or full stack. Most available control platforms are just communication protocols. This leaves the user with missing functionality, which often leads to a patchwork system, riddled with potential security vulnerabilities. In contrast, Blinky-Lite strives to deliver a complete system. Not only does Blinky-Lite provide a set of device interfaces, a communication protocol, and configuration databases, it also provides an alarm system, notification system, device viewers, and plotting packages. The data archiving system also includes access and setting history. User authentication interfaces include one-time password, two-factor authentication. And, instead of name-value pairs, device data is object-oriented, which lends to complex data types, such as vectors and images. There is even an integrated logbook application, with hooks into the notification system. Even though the base stack of Blinky-Lite applications should fit almost all of a user's needs, we know that custom user applications are an integral part of any control platform. However, developing event-driven control applications can be very challenging. So, Blinky-Lite provides an application builder that makes it easy for the user to build her own custom dashboard application, without having to do any programming. The application builder has a basic library of widgets based on Bootstrap 4 cards. The user just configures a JSON file in the Blinky-Lite app database. Currently, the app builder has 9 different types of cards and 13 different types of widgets, which should cover almost all of the use cases a user will need. As I have already mentioned, security was a driving force in developing Blinky-Lite. However, to really understand Blinky-Lite, I need to spend a few minutes describing the Blinky-Lite architecture. The Blinky-Lite architecture is based on Linux containers. A Linux container is a set of one or more processes that are isolated from the rest of the system. All the files necessary to run them are provided from a distinct image, meaning Linux containers are portable and consistent. Because of their popularity and ease of use, Linux containers makes Blinky-Lite very extendable. Containers are also an important part of IT security. For example, all the Linux containers in Blinky-Lite communicate on an isolated container network. Blinky-Lite Linux containers are managed by Portainer, which itself is a Linux container with an easy-to-use web interface. The core containers of Blinky-Lite are the application server, the database for storing data and application configuration, and the notification server for alarm handling. To communicate with internal devices, Blinky-Lite uses an MQTT container. MQTT is a publish-subscribe communication protocol developed by IBM for the monitoring of oil pipelines running through the desert, but is now a very popular IoT communication protocol. A key security feature of MQTT is that every device initiates authentication to the communication broker, and the publish-subscribe topics for each device is linked to a unique device authentication. This is much different than most other control system protocols in which communication to the device is initiated externally, which can compromise security. Also, in traditional systems, devices can be overwhelmed by too many requests for data. However, MQTT provides inherent data pooling. That is, devices only publish data when they are ready, regardless of how many requests from users. As discussed earlier, with Blinky-Lite, the user can only interact with the control system through applications served from the application server. The user accesses the web applications through a reverse proxy server that is configured to permit only appropriate routing requests from the user. Next in the line of defense is role-based authentication. In the Blinky-Lite database, we can assign roles or permissions for each user. These roles limit which applications a user can use, what the user can do in each application, such as read or write, and what data types and data the user can interact with. When the user logs into the control system with two-factor authentication, her credentials are matched against those stored in the user database. Her roles that are defined in the user database are encrypted in a JSON web token. This token is then sent back to the user and is stored as an encrypted cookie in her browser. Each time she interacts with the application server, she presents the encrypted token, and the server decides whether the request can be granted, based on her allowed roles. At this point, Blinky-Lite is perfectly suited for operations inside an internet firewall. However, a remote access control platform is not of much use if you cannot securely access it from outside your facility. For secure remote access, Blinky-Lite provides a tunnel container that sends traffic through the firewall, using a virtual private network. Now, Blinky-Lite goes one step further by routing the VPN to an outbound-only, reverse proxy server, located in the cloud, such as Cloudflare Zero Trust. This reverse proxy server permits only allowed routes to the application server, and provides the first line of defense against the wild world of the internet, such as denial of service attacks. Now we have the configuration for a single Blinky-Lite control system. But, because Blinky-Lite uses MQTT as its device communication protocol, Blinky-Lite can be easily extended to a multi-node distributed control platform, by bridging multiple Blinky-Lite systems to an external MQTT broker. By configuring the topics on the external broker, it is possible to share only a certain subset of devices between Blinky-Lite systems. This configuration provides an excellent balance between data sharing and compartmentalizing. Note, again, that connections to the external broker are initiated from the internal brokers, providing a secure connection. That wraps up our quick overview of the Blinky-Lite architecture. From isolated container networks, to publish-subscribe device communication, to role-based authentication via JSON web tokens, to virtual private network communication through a reverse proxy server, Blinky-Lite provides an organized, layered approach to remote access security. Check out how to install Blinky-Lite at the blinky-lite.org webpage.